Hi everyone, welcome to the next session, design and drawing of reinforced concrete structure. Up to now we are discussed about what is meant by working stress method and what are the different types of design code books, as well as we are discussed about the modular ratio, what is meant by moment of inertia, singly reinforced, under doubly reinforced, balanced section, under reinforced section, over reinforced section. These are the concepts you are discussed in our first chapter, introduction 1, working stress method. Today we will see the limit state method. In limit state method, what are the different types of loading conditions and what are the different types of partial safety factors with respect to the strength as well as with respect to the loading conditions, as well as we will see the assumptions of limit state method under collapse under a flexural condition. Already we are discussed about the limit state of collapse under a flexural condition. Again, one more time I am discussing here the assumptions of limit state of collapse under flexural condition, as well as we will see the what is meant by singly reinforced section and what is meant by doubly reinforced section, how we have to analyze and design the singly reinforced section and doubly reinforced section in a limit state method. We will see. First we will come to the first chapter, that first topic, characteristic and design values and partial safety factors. First I will explain about the characteristic strength, as well as I will explain about the characteristic load. The characteristic strength already we are discussed in our introduction part. Here again I am explaining. Characteristic strength means the value of the strength of the material below which not more than 5% of the test results are expected to fall. According to IS code 456, while you are designing any concrete mix, for this concrete mix, the preparation of the concrete after finishing, you are testing in the compression testing machine. After testing this concrete in compression testing machine, you will get the strength of concrete. That strength of concrete, it will be give below not more than 5% test results are should not follow below the target mean strength. That means suppose for M20 grade I am preparing the concrete. For M20 grade concrete, the characteristic strength it will be 20 megapascal or 20 Newton per mm square. Suppose I am casting 100 cubes. In 100 cubes, all cubes I am tested by using the compression testing machine. In compression testing machine, up to 95% of the cubes that should give the strength more than 20 Newton per mm square. Only 5 cubes or only 5% cubes are expected to fall below the 20 Newton per mm square. If you get the concrete like that, then only we will call it as a characteristic strength. If you observe here, the characteristic strength for concrete shall be according to with the table number 2. If you see the IS 456 2000 Code of Practice and plain and reinforced concrete, we are having different types of grades of concrete: ordinary grade, standard grade, high strength grade. While taking different types of grades of concrete, we are having the different types of characteristic strength. If you consider the M20 grade, for M20 grade the characteristic strength is 20 Newton per mm square. As well as if you take the M50 grade, for M50 grade the characteristic strength is 50 Newton per mm square. As well as if you design the grade for M35, for M35 also the characteristic strength it will be 35 Newton per mm square. That means only 5% test results are expected to fall below the 35 Newton per mm square. If you get the strength like that, that strength what you are gaining is called as a characteristic strength. Next, characteristic load. What is meant by characteristic loads? Already loads we have discussed. Load is the external forces acting on the various type of structural bodies, either in bridge or in a dam or in a retaining structure or any multi-storied building. In this building, there are various type of loads acting on the building. The loads may be either dead load, live load, wind load, snow load, earthquake load, hydrostatic pressure, or flood load. These are the different types of loads are going to acting on the building. If you see here, characteristic load, I am explaining here. The term characteristic loads means the value of load which has a 95% of probability of not being exceed during the life of a structure. That means I am constructing one structure and I am applying a certain amount of load. The load what you are applying on the building, it does not exceed 95% in the life of a structure. Suppose you are constructing the building for 100 years. In 100 years, only 95% of loads are expected to acting on the building. If you design the building in such a way that it will be called as a characteristic load. In IS 875, we are having different types of loading conditions such as dead load, live load, wind load, snow load, earthquake load. Based on these loading conditions, we are having the different types of loading acting agents. That means if you take the kitchen room, for kitchen room, how much dead load is acting, how much live load is acting, all these terms will taken from the IS 875 code book. Okay, now we will see the what is IS 875 part 1, part 2, part 3, part 4. Characteristic load means the value of load which has a 90% probability of not being exceed during the life of a structure. That means after construction of the structure only 95% load will coming onto the building in the lifetime. And if you see here characteristics load, the loads where we are taking is from IS code books. That is nothing but the IS 875. If you see here, we are having different types of loadings already we are discussed. The loads are dead load, live load or imposed load, wind load, snow load and earthquake load. Already all these type of loading conditions we are discussed in our previous lecture. If you see here, dead load is the permanent load which is attached to the structure itself, or the self weight of the different types of members, it will be called as a dead load. Okay, if you see in our surrounding structure, any structure, you will observe the various type of non-movable objects as well as various type of structural elements. That means you are observing the slab, beam, column. Okay, all these elements are the self weight itself will acting on the building components. That load it will be called as a dead load. Some non-movable loads also will comes under category of dead load. The dead loads are different types of loads. We are taking it from the IS 875 part 1. If you consider different types of brick, masonry, aluminum, copper or any other steel members, for all these type of materials, what is the unit weight and how much amount of material weight acting on the building, we will taking it from the IS 875 part 1. And second one is the imposed loads. Imposed loads are nothing but the moving loads. Any furniture, kitchen items, all the moving vehicles or moving persons, all these loads will come under category of the live load. In live load IS 875 part 2, you will observe the what are the different types of live loads and how these loads will be acting on the building. We will discuss in the live load. And next one is the wind load. Wind load means based on the topography of the atmosphere or based on the direction of the wind or based on the place, how much amount of wind is going to act on the building, we will consider from the wind load condition. While constructing or designing any high-rise structures, chimneys or any tower buildings, while designing for such type of structures, we'll analyze the wind load condition. We'll consider the how much amount of wind is going to acting on the building for high-rise structures or any chimneys or any towers. We'll discuss on the wind load. For wind load, we are taking the code book as IS 875 part 3. This is the code book for wind load. And next one is the snow load. If you observe some foreign countries, due to very cold condition, lot of amount of ice will fall on the building. In those conditions, they will also consider the snow loads also. That's why they will construct the roof-like structures to fall down that ice as well as to resist the building. The snow load, all these conditions we are taking from the IS 875 part 4. Next, one more code book also we are having, IS 875 part 5. In IS 875 part 5 we are taking the combination of the different types of loading condition. That means dead load, live load, wind load, as well as dead load, live load, earthquake load. All these loads at a time you are considering while designing the buildings. That loads it will be called as a combination of loads, that it will become under category of 5. Okay. And next one is the earthquake load. Due to underground movement of the tectonic plates, the vibrations will come into the structure. Due to these vibrations, the structure may move underground. Due to this foundation movement, the structure also will get failure. How much amount of earthquake is coming, for how we have to design the building based on this earthquake loads also we will discuss in the IS 1893 2002. Recently one more code book also came into existence, that is criteria for earthquake resistance design of structures, IS 1893 2016. That is the recent code book. Instead of 2002, one more code book is came, that is 2016. Okay. These are the different types of characteristic loads we are taking from the IS code book. Well, if you are there in class, by seeing code book itself, we will discuss the what are the different types of loading conditions, how these loads will acting on the building. We will discuss in our regular classroom lectures. Next, we will see the design values. Design values are nothing but while designing any type of a structure, we are considering the how much amount of the load will be going to acting on the building, or how much the structure will be stable with respect to the sectional loading condition, or what is the maximum strength of the members we are providing in the building. That all parameters we are taking here from the design values. From class number 36.3 IS 456 2000 Code of Practice for Plain and Reinforced Concrete, we are taking the various type of design material values. If you see here, the design strength of the material FD is given by the equation here, where FD equal to F divided by gamma M. The design strength of the material is given by FD equal to F divided by gamma M, where F it will be called as a characteristic compressive strength of the material. Characteristic compressive strength of the material. And gamma M is the partial safety factor, where gamma M is the partial safety factor appropriate to the material and limit state being considered. And while we are designing any type of structural member, we will take the characteristic strength as well as we will take the partial safety factors. If you observe here characteristic strength means already we are discussed. By using various type of ingredients of concrete, we are making the concrete. If you see here, where M30, in M30, 30 is the characteristic strength of the material. That means if you want to design for any type of building, we have to calculate the design strength by taking the characteristic strength with respect to the partial safety factor. Here I am taking the characteristic compressive strength value as 30. I am taking the characteristic compressive strength value as 30 divided by where gamma M is the partial safety factor. For concrete I am taking the partial safety factor as 1.5. For concrete I am taking as the partial safety factor as 1.5. If you substitute these values, you will get the characteristic compressive strength of the concrete. What we are doing? I am substituting here 300 divided by 15. 15 ones, 15 twos, that equal to 20 Newton per mm square. This is the design strength of the material for various type of structures what you are being constructing in the structure. The characteristic compression normally we are getting 30 Newton per mm square. But while coming into existence, we are considering only 20 Newton per mm square for the structure. That means if you take our building, for this building we are taking the design value of the strength as 20 Newton per mm square only. Next we are having the loads. What are the characteristic loads we are discussed? Now we will discuss about the design load. What is meant by design load? How the loads we are taking from the based on different types of loading conditions already we are discussed. Now according to IS 456-2000 Code of Practice from plain and reinforced concrete structure, I am taking it is from IS 456-2000. I am taking it from IS 456-2000. Clause number 36.3. Through load. The design load FD is given by FD equal to F into gamma F. Design load FD is given by FD equal to F into gamma F, where F is called as a characteristic load. And gamma F is called as a partial safety factor. Again, this characteristic loads we are taking from the various type of loading condition. That means if you are taking wind load or dead load or live load or imposed load, either imposed load or earthquake loads, all these loading conditions based on the IS 456 code book will take the characteristic load. If you see here our daily buildings such as either kitchen, room, hall, staircase, veranda, for all these type of structures we are having due to dead load it will lack some amount of load. That load may be 2 kN per meter square based on the self weight of the material. As well as if you consider the for normal bedroom, in normal bedroom the live load it will be 2 kN per meter square. Based on those code books we will consider the characteristic load based on the loading condition as well as based on the type of the load. And gamma F is the partial safety factor we are taking on the based on codal provisions. And if you see here the design load and design strength partial safety factors, one more table I am inserted here. This is the image I am copied from our code book IS 456-2000. If you see here, this is the code book substituted values. I will see next image also. Design load equal to here design load equal to characteristic load into partial safety factor for the load. Design load equal to characteristic load into partial safety factor for the load. Characteristic load we are taking from the various type of loading condition. That load may be dead load, wind load, seismic load. From IS 875 code book we are taking the characteristic load. But how we are taking the partial safety factor? From this table 18 values we are taking the partial safety factors for the loading condition. In IS 456 itself they are giving the some partial safety factors for loading conditions. If you observe here the load combinations we are having dead load plus imposed load or live load. One more load combination is dead load plus wind load, and one more load combination is dead load plus imposed load plus wind load. And if you observe here, for designing different types of structures we are considering the limit state of collapse as well as limit state of serviceability. For the limit state of collapse we are considering for the flexure condition, compression condition, torsion condition, shear condition for limit state of collapse. Whereas for limit state of serviceability we are taking the deflection, cracking and vibration. That means you are designing some structural element. For designing this some structural element, what parameters you are considering to design the structural members. That means if you want to design the member without it's getting any type of flexure, compression, shear or torsion, if you want to design like that, we have to take these loading condition, these factor of safety. Otherwise, if you want to design the structure without getting any vibrations, cracks or deflections, we have to design the loads by using these values: limit state of serviceability, limit state of collapse. If you see here, for dead load we are taking the partial safety factor as 1.5, and if you consider the wind load, partial safety factor we are taking it as 1. Again, suppose I am taking the building for dead load I am taking for building as 10 kilonewton per mm square. Suppose it is acting on a building, the dead load I am taking it as a 10 kilonewton per mm square. Normally it is acting. Now I want to calculate the designed value or design load. For design load, what we are having? Design load we are having FD equal to characteristic load into partial safety factor. For design load, FD equal to characteristic load into partial safety factor. Here characteristic load I am taking it as 10 kilonewton per mm square. 10 kilonewton per mm square, and I am taking the partial safety factor under the condition of limit state of collapse. For limit state of collapse, for dead load condition, I am considering the partial safety factor as 1.5. That is 10 into 1.5. That equal to, I am substituting the 10 into 15. I am getting it as 15. That means 50 kilonewton per meter square. That means actually the load coming on the building is 10 kilonewton per meter square only, but I am considering it as 50 kilonewton per meter square. Why? Because in future if there is any maximum amount of load also occurring, the structure it will may resist. Suppose first you are constructed some building, some one-story building. Now again you want to construct second story on the top of the first story. What it will happen? The load of the second story will acting on the column. If you while designing the column for first story itself, how can you construct the second story on the building? That means the load is exceeding. That means the load is beyond the design load. In those conditions, the building will may collapse. Hence why we have to calculate the partial safety factors for different types of loading condition. By seeing this table, we can substitute all the partial safety factors. We can multiply with the characteristic load. You will get the design load values in the structure. The same table we will see in table itself. And if you see here, partial safety factors according to IS 456-2000, and here limit state of collapse. This is first condition. And the second condition is limit state of serviceability. In limit state of collapse, we are considering for compression, flexure, shear and torsion. That means the member due to loading condition, it may act any of these following forces. That means compression it will may happen, flexure it will may happen, shear it will may happen, torsion it will may happen due to the loading condition under limit state of collapse. If you see here, for concrete we are taking it as the partial safety factor as 1.5. Concrete we are taking the partial safety factor as 1.5. For steel we are taking the partial safety factor as 1.15. For steel we are taking the partial safety factor as 1.15. Concrete we are taking the more partial safety factor. Why? Because concrete we are making in the site itself in an uncontrolled manner. Hence why concrete it does not give the accurate strength after construction of the structure. Hence why we are taking the partial safety factor for concrete is more compared to the steel. Where in steel manufacturing industry they are manufacturing the steel in a very accurate manner. Hence why we are reducing the factor of safety for steel. And if you see here, the ultimate load values. Now, ultimate load values are the design load values. Normally we are taking in first example we have seen about the 10 kN per meter square. That is the normal load. But ultimate load, by substituting the factor of safety, you will get the ultimate load. If you see here, in first condition we are taking that 1.5 times of dead load plus live load. How much amount of dead load we are acting on the building and how much amount of live load acting on the building. If you substitute the 1.5, you will get the design load. And as well as this is one more condition, 1.5 dead load plus wind load, or 0.9 dead load plus 1.5 into wind load. And this one is the one more condition, ultimate load equal to 1.2 into dead load plus live load plus wind load. These are the three conditions we are considering for the design of a structure based on the limit state of collapse. For considering limit state of collapse only, we are taking these values. Again, if you consider the limit state of serviceability, limit state of serviceability is nothing but if you design any structure, this structure it should not give any deflection, cracks or deformation throughout its lifetime. Otherwise, this structure it should not be unserviceable in its lifetime. The building or the structure what you are designing, the design structure it should not be unserviceable in lifetime. If you design the structure in such a way that it will be called as a limit state of serviceability. Again, for limit state of serviceability, we are taking this partial safety factor for concrete as 1.0, as well as for steel we are taking it as partial safety factor as 1.0. If you see here, for serviceability loading conditions, these are the different types of partial safety factors we are considering. For serviceability, we are taking 1.0 into dead load plus live load. For again serviceability load, if you want to consider wind load, for wind load also we are taking it as 1.0. Suppose if you want to calculate the dead load, live load and wind load, for dead load, live load, wind load, we are calculating as 1.0, 0.8 of live load, that's 0.8 of wind load. These are the different types of codes based on the limit state of serviceability. Up to this is the characteristic loads as well as design loads based on the IS code 456 code. Now, if you see here, again from class number 36.4.2.1, from class number 36.4.2.1, when assessing the strength of a structure or structural member for the limit state of collapse, the value of partial safety factor you should be taken from the IS 456 code book. From the IS 456 code book, we are taking the partial safety factor for concrete as 1.5. 1.5 is the partial safety factor for the concrete, whereas 1.15 is the partial safety factor for the steel. For steel, we are taking the partial safety factor as 1.15. These are the very most important bits. These bits will be asked in our online examination questions also. You have to remember these values. Next, we will discuss about the elastic stress and strain behavior of a material. We are going to discussing about this stress strain of various type of mild steel or cold deformed bars. Again, I will explain about the topics what we have discussed up to now. We have discussed about the characteristic strength. We have discussed about the characteristic load. We have discussed about the design strength. We have discussed about the design load, as well as we have discussed about the different types of loading conditions. We have discussed about the partial safety factors for different types of dead loads, live loads and wind loads, limit state of collapse and limit state of serviceability. Next, welcome to the next topic. In next topic, we are having the elastic stress and strain behavior of a material or stress strain diagram. Engineers, they are considered different type of materials they have taken, and they consider the material how it will be behave due to the various type of loading condition. That means if you take any structural member, any engineering material, If you apply the load, due to application of the load, the material will give some result. That means will give some deformation, cracks, deflection. How different type of materials are deforming or straining due to different types of loading conditions. They are given the different type of stress strain diagram for different types of material. If you observe here, it is a tool for understanding the material behavior under loading. Especially for civil engineers, we are constructing the building by using different types of materials. For these different type of materials, due to application of the load, how the material may respond with respect to the any external forces or any internal forces, that is the main object of a civil engineer. That means we have to know the due to application of the load, how various type of materials will behave with respect to the loading condition. In our design and drawing of reinforced concrete structure, majorly we will see the two materials, that is nothing but concrete, and second one is the steel. Again, if you consider the concrete, in concrete we are having again different types of ingredients: cement, fine aggregate, coarse aggregate, as well as some other admixtures. It may be rice gas, fly ash, that may be different. But steel and concrete, we have to know stress and strain diagrams. And while coming to this stress strain diagram, generally we have three types of failures or three types of behaviors while we are observing on any material due to the application of the load. If you take any material, in material I am applying certain amount of load. Due to this application of the load, the material will may deform or may give three types of responses. That response is what we are discussing here. If you see here, the first one is the elastic region. That means if you see here, elastic, what is meant by elastic region? Elasticity, it is the property of a material. Due to application of the load, the material will may elongate, and if you remove the load, the material will regain its original shape or original position based on the elasticity nature of the material. If you see here, for any type of material, due to application of the loading condition, we will observe three regions. That is, first one is the elastic region, and next one is the plastic region, and third one is the rupture region. If you see here, this portion is generally represented as a linear relationship. It is most important. Linear relationship between stress and strain. If the load is released, this specimen will return to its original dimension or original position or original shape. That means here I am taking some structural member, structural bar, and I am applying the some amount of load. This amount of compressive force, the member will may compress in this direction. It may be in a bit long direction as well as lateral direction. It will may compress like this. Again, if I remove these loads, again the body, it will may regain to its original position. That means stress is directly proportional to strain. Stress is directly proportional to strain, then the member will may get it to original position. And next one is the plastic region. In this portion, the specimen begins to yield the maximum strength of the specimen occurs in this zone. The specimen endures some permanent deformation due to the application of the load. In plastic region, what it will happen means, I am taking some structural member and I am applying the certain amount of load. Due to this application of the load, the deformation it will may happen. And again, if I am remove the load also, the deformation won't come into its original position. Why? Because the material is already acted to the permanent deformation. Extension is already happened. Due to this plastic nature, the material it will may won't get to the original shape or original position. That is the plastic region. If you observe here near any your surrounding, we are having different types of plastic elements. That means first they will give that to elasticity nature. They will keep to the plasticity. They will mold into particular shape, and then they will give the elastic property to the building. This is the stress strain diagram for the plastic region. And next one is the rupture. Rupture is nothing but the point at which a specimen breaks into 2 points. That means again due to application of large amount of load, first in condition the material will have some elastic property. Again if you apply the load lot of, again the material will go plastic deformation. That means again if you remove the load, the member won't get into the original position. As well as if you are increasing the load, due to this increasing of loading condition, the material will go away, and finally the material may break into 2 pieces, or it may be rupture into 2 pieces. If you observe here the stress strain diagram for the ductile material. While going to discussing about the stress strain diagram of ductile material, I will explain about the what is meant by ductility, what is meant by brittleness also. If you see here, this is the stress strain diagram for some ductile metal, that means maybe mild steel, copper or aluminum. If you see here in a y-axis I am taking it as a stress, and x-axis I am taking it as a strain. That means I am taking some structural steel or copper, aluminum, and I am applying the load. Due to this application of the loading condition, the member will get to the strain. That means length it will may change. Based on the compression forces, length it will be decreased. Based on the tangential forces, length it will may enhance. If you see in this diagram, see, while I am applying the load, due to this application of the load, the material will may get yielding. That means strain is coming. If you see here up to this portion, the material is in a elastic region or elastic limit. That means how much amount of load you are giving, the material will also go to that much amount of strain. Up to this elastic limit, if you remove the load, after removing of the load also, the member will may get reback to the original position. For example, if you take your classroom duster, sponge duster, in sponge duster I am applying some tangential force. Due to this tangential force, the sponge will may get extend beyond the original length. Suppose this is 10 cm length, and if you drag like this, the 10 cm sponge it will may extend. That means it may be either 12 cm, 14 cm based on the elastic property of the material. After extending some distance, if I am remove the load, what it will happen? The sponge may again will get into the original position. That behavior we will call it as a elastic limit. Up to elastic limit, stress is directly proportional to strain. If you apply the load, strain will may happen. If you remove the load, strain will again get into its original position. And next one is the up to elastic limit to yield point. We are having the plastic region as well as we are having the yield point. In yield point, again we are having the lower yield point and upper yield point. This lower yield point and upper yield point we will discuss. And after that elastic yield point, we are having the plastic region. In plastic region, again what we are observing means, due to this application of the load, the member will may get into the some extension. Again, if you remove the load, due to removal of the load, the member will may not get into the original position, because the material will lost its elastic property. The material lost its elastic property and it enters into the plastic state. Due to this plastic state, if you remove the load also, the member won't get into the original position. And next one is the rupture portion. In rupture portion, what will happen? Again, if you are increasing the load, due to this continuous increasing at certain amount of load, the material will may breaks into 2 pieces. That is the concept of rupture. Where the material will breaking or rupturing, that point it will be called as a ultimate strain, or that load it will be called as a ultimate load. We will discuss it in the briefly. Okay, now see here. Again we will see briefly what is meant by elastic limit, what is meant by plastic limit, and what is the proportional limit, what is upper yield point, what is lower yield point, what is breaking failure, rupture failure, we'll see in detail. Here if you see here, stress strain diagrams are generated experimentally throughout the performance of a controlled tangential test using the fabricated testing specimens. That means for knowing the different types of member due to application of the load, how the strain is getting onto the members. Based on this straining condition, based on the tangential test equipments, we will know the different types of materials. With respect to the loads, we will calculate the strain values. If you see here, the applied load and the displacements are monitored during the test and are used to calculate the stress and the strain respectively. That means we are having one equipment called universal testing machine. Already you have studied in your strength of materials laboratory. And if you see here, due to the application of the load and the displacement, it will may happen to the structural members. If you take any member, if you apply the load, due to this application of the load, the member will give some deformation, some displacement. That will be called as a stress and strain. The temporary displacement is called as a deformation of the body. Now we will see the diagram equipment, and if you see here, this is the universal testing machine which is used to find out the stress and strain for different types of steel materials, especially for copper, aluminum and steel. If you see here, this is the experiment equipment already we have studied. Briefly I am explaining here. Here I am steel rod I am taking and I am applying this load. Due to this application of the load, the member will get split into two portions. After while conducting this experimentation, due to the application of the load, the material will behave in different ways. That means if you will doing the experiment in the laboratory, the material what you are keeping in this equipment while applying the load, due to this application of the load in various loading conditions, the material it will may behave very differently. How it will behave very differently, we'll see next slide.